Hello, everyone. My name is Abhishek, and today we are going to discuss lecture number 3 of chapter Quadrilateral of class ninth. And as we before we start discussing the topics, it's very important to understand the weightage of the weightage of this chapter as far as your school examination is concerned and your competitive examination is concerned. So, if I talk about school examination, then you can expect questions which carries around 3 to 4 marks, although it varies from school to school. Let me make it very clear, it might vary from school to school, but you can expect at least 3 to 4 marks problem from this chapter. And in IMO, which is conducted by SOF, here we are talking about SOF IMO. In IMO, you can expect around 2 to 3 questions from this particular chapter, because geometry forms an integral part of any competitive examination, which includes mathematics and ninth standard. Okay. Now let's move ahead and see which topics are we going to cover in today's session. All right. So the topics that we are going to cover in today's session, there are two important theorems that we have. The first theorem, the name of the first theorem is midpoint theorem. Extremely important theorem. Let me make it very clear. It's very important. Okay. The proof is very important. Okay. So we should know the proof of this theorem. Apart from this proof, we should know the statement. We should know the statement by heart. And the last thing which we should be aware of is the application, or we should know how to use this theorem to solve the problems. The second thing which we are going to cover in today's session is the converse of the midpoint theorem. What are we going to do in this second theorem? In this second theorem, whatever will be provided to us in the midpoint theorem, that thing we are going to prove in converse of midpoint theorem, and whatever we proved in midpoint theorem, that will be given to us in the converse of midpoint theorem. So we are going to discuss that as well. So both theorems are extremely important. I should mention that the proof is important, the statement is important. You should also know how to apply these theorems to solve the problems. Like, these three things are extremely important as far as these two topics are concerned. All right. So we are going to start our session with the midpoint theorem. Right. Let's move ahead. All right. So here, first I will tell you what is the meaning of each and every word which is written in the statement of the midpoint theorem. The midpoint theorem says that the line segment joining the midpoints of two sides of a triangle. Okay, two sides of a triangle. So if I talk about the given figure, guys, then in this figure, which in this triangle ABC, we have a line segment. That line segment is DE, and this line segment is joining the midpoint of the side AB and AC of the side AB and AC of triangle ABC. So what are we provided here? We are provided that in triangle ABC, in triangle A, B, and C, D and E. Okay, D and E are midpoints of D and E are midpoints of AB and AC respectively. Okay. Or you can also write, we are given that AD is equals to DB and AE is equal to EC. You can write that as well. Okay. If you read this statement further, what does it says? It says the line segment joining the midpoint of two sides of a triangle is parallel to the third side of the triangle and is half of it. What does that mean? That means if you have a line segment which is joining any two sides of a triangle at the midpoint, so here that line segment is DE, then we have to show that that line segment, which is DE in our case, that is parallel to the third side. That third side in this situation is BC, and that line segment DE is also half of that. Okay. So we have to show two results. First is this DE is parallel to BC. Okay, that's a result number one. And the second result which you have to show is this DE is half of BC. Okay, these two results we have to prove in this midpoint theorem. Okay. Now the thing is, we need to do some construction here to prove this theorem. And what is that construction? So first let me write that construction, then I will show you that in the figure as well. You need to produce this DE to F. You need to produce DE to F such that your DE is equals to DE is equal to EF, and after that you have to join CF as well. Okay, so this DE that you have here, it has been extended to point F such that this DE is equal to EF. Okay, and thereafter we join C and F, and we are already provided that AD is equal to DB as D is midpoint of AB, and we are also provided AE is equal to EC as E is the midpoint of AC. Okay, now let us proceed to the proof, and be very attentive while I explain the proof of this theorem. If you feel you haven't understood any of the step, stop me there, ask me how I got it, what's the reason behind it, like how, like what, like anything, any problem that you face while I prove this particular theorem, stop me right then and there and ask me that particular thing. All right. So I think we should move to the proof of this theorem. Check out. So proof is very simple actually. We are going to consider triangle ADE. So in triangle ADE, okay, and we are going to consider triangle CFE. CFE. So triangle ADE, we have considered this triangle, and we have considered triangle CFE. Okay. So in these two triangles, it's very clear that AE that you have, it is equals to what? It is equal to EC. Okay. This is given to us, right? Angle AED that you have, that's equals to what? That is equals to angle CEF. Why? Because these two angles are vertically opposite angle. I hope everybody knows what vertically opposite angle is. And the third thing which you have is DE is equal to what? DE is equal to EF. Okay, that's what we have, right? Again, this is by construction, I would say. This is by construction. So can we say that the two triangles under consideration, that means these two triangle ADE, it is congruent to triangle CFE by SAS rule or not? Because two sides, okay, and the corresponding angle of the two triangle of one of the triangle is same as the two sides and the corresponding angle of the other triangle. So without hesitation, we can say that these two triangles given to us, they are congruent to each other by SAS rule. Okay, so let's move to the next slide. So yeah, all right, therefore we can say triangle AED or ADE is congruent to CFE. Okay, so I'm writing it here. Triangle, therefore we have triangle ADE is congruent to triangle CFE by which rule? SAS congruency. Okay, or SAS rule. Right, let me draw that rough figure here so that we don't need to scroll back again and again. So this was the triangle, this was the line segment we had, and this was that side. This was A, B, C, D, E, and that was F. Okay, so this angle was equal to this angle, this side was equal to this side was equal to this side, and this side is equal to this side. All these things were given to us. So if these two triangles are congruent to each other, then it can be said that angle ADE that you have, it will be equal to angle CFE, right? By CPCT, right? These two angles are going to be equal by CPCT. CPCT stands for corresponding parts of congruent triangles. That means if you have two congruent triangles, then their corresponding parts are also going to be of same length, you can say, if we are talking about sides, or the angles are going to be same if we are talking about angles. Also, what do we have? We have AD is equal to what? AD will be equal to CF by, again, like due to the same reason, which is CP/CT. Okay, let me call this result as third result. Okay, now if triangle ADE, guys, if triangle ADE, right, it is equal to CFE, right? Triangle ADE means this angle is equal to CFE means this angle. So can we say that this line segment AD will be parallel to CF? Because if these two angles are equal, then these two angles are actually forming alternate interior angle. And if the alternate interior angles are equal, then the lines are parallel to each other, right? So we can say as angle ADE, okay, is equals to angle CFE. Therefore, it can be said that AD is parallel to FC. Okay. Reason is alternate interior angles are same. Alternate interior angles are same. Okay. And if AD is parallel to FC, then it can be said that AB is also going to be parallel to FC, right? Because AB you will get, if you extend that line segment AD to B, you are going to get AB. So it can be said that AB is also going to be parallel to FC. Let us call this as result number 4. So what do we have now, guys? We have DB is parallel to FC, okay? Or you can say BD is parallel to CF, whatever you want to call. Apart from that, what do we have? We have AD is equal to CF, right? AD is equal to CF. But it is given to us that this AD is already equal to BD, right or not? So from 3 we have, what do we have? We have AD is equal to CF, okay? But we also know, but we have AD is equal to BD, that is given to us, right? Given. Therefore, can we say that this DB or BD, whatever you want to call it, this BD is equal to CF. We can say this from this result, that is result number 5 if you want to call it, and result number 6. Because AD is equal to CF and AD is also equal to BD, therefore BD is automatically going to be equal to CF, right or not? Because if X is equal to Y and Y is equal to Z, then you can say that X is also equal to Z. So by using this property, you can say without hesitation that BD is nothing but it is equals to CF, right? Now check out. BD is equal to CF, right? Also, what do we have? We have BD. BD is parallel to CF, right or not? From result number 4. BD is parallel to CF. And we know that whenever in a quadrilateral you have one pair of opposite side equal and parallel, okay, then that quadrilateral forms parallelogram, right or not? We know in a quadrilateral, when one pair of opposite sides is equal as well as parallel, I repeat, in a quadrilateral, when one pair of opposite side is equal and parallel, then the quadrilateral forms a parallelogram, okay? Therefore, we can say, I'm writing it here. Therefore, we can say that this figure you have, BCFD, is a parallelogram, right? This is a parallelogram, correct? And we know that in any parallelogram, the opposite sides are always parallel as well as equal. So since BCFD is forming a parallelogram, so can we say that DF is parallel to BC, right? And DF is equal to BC. We can say that, right or not? DF will be parallel to BC and DF will be equal to BC because these are opposite sides of parallelogram. Okay. And it's very clear, if DF is parallel to BC, automatically DE is also going to be parallel to BC because DE is a small part of this DF, right or not? I repeat, because DF is parallel to BC, Therefore, DE is going to be parallel to BC automatically, as DE is a part of this line segment DF. So we can say that DE is parallel to BC, and this proves our first part. Okay, I am highlighting this. This proves our first part of the theorem, that is DE is parallel to BC. Now, what do we have? We have DF is equal to what? BC, right? We have DF is equal to BC, and we can write DF as DE plus EF. DF can be written as DE plus EF. So DF is equal to BC means DE plus EF is equal to BC. And by construction, we can replace EF by DE because both are same. That's how, like, we kept this thing in mind while doing construction. So what can be done? In this case, I can replace this value EF that we have by DE. So if I replace that, I will be getting DE added to DE is equal to what? That would be equals to BC. Understood? And if that happens, what will you get? You will get twice of DE is equal to BC, right? And if you move 2 to the other side, you will be getting DE is equal to 1 by 2 times of BC, right? So that proves the part 2 of this theorem, which is the line segment that is under consideration, that is half of the third side. So in this theorem, let me repeat what we are given and what you have to show. In this theorem, you are always given a line segment which is passing through the midpoint of any two sides. In our situation, we took those two line segments as AB and AC. Those two sides as AB and AC, and the line segment was DE. This DE was passing through the midpoint of AB and AC respectively. And we were supposed to show that this DE is parallel to the third side, which is BC in our situation. We already showed that here. You can check out. I'm going to encircle that, right? We showed that thing here. And this is half to that side. That means we were supposed to show that DE will be half of BC. That part also we have shown here. Okay. I hope this proof is very much clear to all of you. You can note it or you can go through it once to understand what all we have done to get this result. All right. Okay, I hope everyone got it. We can move then to the next slide. Check out. All right. So here we have the second theorem, which is actually the converse of the first theorem, which was given to us, the converse of midpoint theorem. So here the result which we proved in midpoint theorem, that will be given to us. And the result which was given to us in the midpoint theorem, that we have to show here. You can read the statement to understand that thing here. You are given, and now what does the statement says? It says the line drawn through the midpoint of one side of a triangle parallel to the base of a triangle bisect the third side of a triangle. Okay, the line drawn through the midpoint of one side of a triangle. All right, so what is given to us here, guys? Here we are provided in triangle PQR that you can see in the figure. This S is the midpoint of PQ. Okay, S is midpoint of PQ. That is what has been given to us. Okay, parallel to the base of the triangle. Also, what are we provided? This is the first thing. We are also provided that this line ST that you have, it is parallel to QR. Understood? The second thing which is provided to us here is this ST that you have, it is parallel to QR. Understood? Now, what do you have to show? You have to show that it bisects the third side of the triangle. The third side means we are talking about side PR in the triangle, which you can see on your screen. So what do you have to show? You have to show that this T is midpoint, T is midpoint of T is midpoint of PR. That is what we have to show here. All right. So I hope you got what has been provided and what we have to show here. We are given a triangle PQR, and in this triangle PQR, we are given that this line ST, it is passing through the midpoint of one of the side, which is PQ. That means S is the midpoint of side PQ. Apart from that, we are given that this ST is parallel to QR, and you have to show that this T is the midpoint of QR. Okay, that is what you have to show here. Let's see what can be done. Here, what do you suggest, guys? Like, what should we do? What construction should we do in case we need to do some construction? What should be that? And if you feel without construction also it can be done, tell me like how to do that. How to do that? Okay, good suggestion. What about others? Check out what construction can be done here. The construction that I'm going to do here is this. Okay, I'm going to assume that this point T is not the midpoint of PR. On the other hand, I'm going to choose one more point. You can say E, which is the midpoint of PR. Okay, and I'm going to join SE. So the construction here is this. Construction is okay. Assuming T is not midpoint, T is not midpoint of PR, we draw a line, segment SE, okay, intersecting PR at E, such that E, or such that you can say PE is equals to ER. If I'm saying PE is equals to ER, that automatically means that E is the midpoint of PR. Okay, so that is the construction which we have done. Now let us move to the proof. Okay, if E is the midpoint of QR that you have, okay, if E is the midpoint of QR, so can we say by midpoint theorem, guys? Check out in triangle PQR. Okay, in triangle PQR, S is the midpoint of PQ and E is the midpoint of PR as per construction. In triangle PQR, can we say that SE is parallel to QR and SE is half of QR by midpoint theorem? Can we say that or not? By midpoint theorem, right? Because the condition necessary for the midpoint theorem is that you should have a line segment which is passing through the midpoint of any two sides. And in our situation, what is happening? In our situation, you can observe S is passing through the midpoint of PQ and E is passing through the midpoint of PR as per our construction. Okay. So what do we have here? We have SE is parallel to QR, right? SE is parallel to QR. But what are we provided here? We are already provided that ST is parallel to QR. So let me call it first result. Let me call this result as second result. Okay. Let's move to slide number, next slide. Okay. So if you check here, guys, what do we have? we have ST is parallel to QR and SE is parallel to QR. Okay. So what does it says about ST and the other side that we have, which is SE? What does it says? It says that both the lines are parallel to the same line segment, which is QR, and both the line segment, that is ST and SE, they have one of the common point, or one of the endpoint is common to both of them, right or not? Because one of the endpoint when it comes to ST is S, one of the endpoint when it comes to SE is S, right? So this line segment ST and SE, they both have a one common endpoint, and they both are parallel to the same line. But is it possible for the two different line segments to be parallel to the same line segment, provided that they both have one common endpoint? That is possible only in one situation, guys, right or not? That is possible only in one situation. And what is that situation? That situation is if this T and E that you have, they coincide with each other. If this T and E, they do not coincide with each other, then this situation is not possible at all. Correct or not? Right? Basically, from result number 1 and 2, we can say that these two intersecting line segments that you have, SE and ST, they are parallel to the same line QR. Okay. So I'm writing here from 1 and 2, from 1 and 2, we can say two intersecting lines segments ST, and what was the other line segment we were having? ST and SE. ST and SE are parallel to same line segment QR, are parallel to same line segment QR, right? Now, in which situation is this condition possible, guys? If you have two intersecting line segment where the point of intersection is S, and both the line segments are parallel to the same line segment, what does it says about the lines, guys? Then does it actually violates the parallel line axioms or not? What does parallel lines axiom says? Parallel line axiom says that if you have three lines, guys, okay, let me show you what we are trying to say here. Let's say you have a line L1, okay, you have one more line which is L2, okay, such that L2 is parallel to L1, right? And L3 is parallel to L1. So both these lines are going to be parallel to each other. Or in other words, you can say all the three lines, that is L2, L1, and L3, they are going to be parallel to each other at the end, right? So this statement that we have here, that we have two intersecting line segment ST and SE, which are parallel to the same line segment QR, right? This statement in itself contradicts the parallel line axioms that we have, right? This contradicts parallel line axiom, right? Therefore, we can say our assumption is wrong. Therefore, our assumption, what was our assumption? That T is not a midpoint. Our assumption is wrong. Okay. Hence, our assumption is wrong. What was our assumption? Let me show you that also. Our assumption was T is not the midpoint. Let me highlight that, guys. Our assumption was T is not the midpoint of PR. That assumption is wrong. Since our assumption is wrong, therefore we can say that T is the midpoint of PR. Okay. Hence, T is midpoint of PR. Okay. And that proves your converse of midpoint theorem. Is that clear? So you have to, because this theorem is little bit theoretical in nature, so you have to revise it, re-revise it to understand it thoroughly. Okay, you need to understand the logic behind each and everything to be able to understand it properly. Is that clear to everybody? Okay, so yeah, you can check here as well. Let me quickly go through this proof once again. Okay, what does the converse of midpoint theorem says? It says S is the midpoint of PQ. Okay, and ST is parallel to QR. Then you have to show that T is the midpoint of PR. But we use the method of contradiction here. And while using that method of contradiction, what I did is I assumed that T is not the midpoint of PR. On the other hand, I have chosen any other point, which is E, and that point E is acting as a midpoint of PR. Now, S is midpoint of PQ and E is midpoint of PR. So, by midpoint theorem, what are we going to have? You are going to have SE is parallel to QR and SE is going to be half of QR, right or not? But what are we provided? We are already provided ST is parallel to QR. So if you pay attention to result number 1 and result number 2, it is very clear that you have two intersecting line segment. What are those two intersecting line segment? One of the intersecting line segment is SE and the other line segment is ST. These two line segments are intersecting each other at S, and both the intersecting line segments are parallel to the same line, which is QR, which is not true, guys, as per parallel line axiom, isn't it? For example, let me make you understand that once again. If you have a line, let's say AB, okay, and you have two intersecting line segment, let's say one of the line segment is PQ and the other line segment is, let's say, PR, then it is not possible at the same time for both of these line segment, that is PR and PQ, to be parallel to the same line, which is AB. Your PQ might be parallel to AB, but if your PQ is parallel to AB, your PR will not be parallel, right? And if PR is parallel, PQ will not be parallel, as PR and PQ both are intersecting here. So this actually contradicts your parallel line axiom here, right? And since it contradicts your parallel line axiom, that means the assumption that we made in the beginning is wrong. Therefore, you can say that T is the midpoint of PR, and that is exactly what we were supposed to show in this problem. I hope this is very clear to all of you. All right. You have 20 seconds, go through it, and then I'll tell you the application of these results as well. Hi guys, so just now we discussed the midpoint theorem and the converse of midpoint theorem. So now we are going to learn the application of these theorems, like how you can use these theorems to solve the problems or to get the answer to the different problems. Okay, so let's take one problem here. What are we provided? We are provided here in triangle ABC, the midpoint of in triangle ABC, the midpoint of BC, okay, CA and AB are DE and F. Given 14 centimeter, what will be the value of EF or FE, whatever you want to call it, if the length of BC is provided to us? So we do midpoint theorem. The midpoint theorem says that if we have a line segment which is joining the midpoint of any two sides of a triangle, right, then that line segment is parallel to the third side and is half of that side. So if I use midpoint theorem here, then in triangle ABC that I have, in triangle ABC, I am given F is the midpoint of AB. That means AF is equals to FB. And I'm given E is the midpoint of AC. That means AE is equal to EC, right? So as we are provided in triangle ABC, as F and E are midpoints, of AB and AC respectively, of AB and AC respectively. So we can say, therefore we can say that this FE, it will be parallel to BC, right? And at the same time, this FE is also going to be half of BC. And what's the reason behind it? The reason is midpoint theorem, right? Now we are already provided the length of BC, right? We are already provided the length of BC, so we can substitute the value of BC here, And if you do the calculation properly, you will get the length of FE or EF. Okay. So from here, what do we have? We have EF or FE. EF is half of BC. That means it is going to be half of 14. And 1 by 2 into 14 gives you nothing, but that is equal to 7 centimeter. Okay. So that means this EF that you have, and that EF is going to be 7 centimeter if BC is given 14 centimeter, and F and E, these are the midpoints of the two sides of the triangle. Clear? I hope it's clear to everybody. If anybody has any doubt, you can ask me in this problem. If you have any doubt, you can ask me. Okay. All right. Okay, no doubt. All right, let's move ahead. You can check here. The answer given is EF centimeter. EF is equals to 7 centimeter, and this solution is for your reference, guys. You can refer it whenever you would like to. Okay. Let's see one more example. Ah, that's a good example. In this problem, what are we provided? Let's read it. L, M, N are three parallel lines. Okay, so let me mention here. This line L is parallel to M, and that is parallel to N. Okay. P and Q are two transversals. So this is P and that is Q basically. Okay. Two transversal intersecting parallel lines at A, B, and C. A, B, C, D, E, F. That's very clear from the figure provided, and we are also given that AB ratio BC is 1:1. If that is given to you, they are asking you what is the ratio of DE and EF. Okay. So here we are going to use midpoint or maybe converse of midpoint. We will see like what is the situation. We are given L, M, N are three parallel lines. PQ are transversal. Okay. If AB ratio BC is. So I am given, what am I provided? I am provided AB upon BC. That's equals to what? That's equals to 1 upon 1. Okay. Or in other words, you can say AB is equal to BC. Okay. That's what I am given. Right. If AB is equal to BC, what does that mean? That means B is midpoint of point of AC. Right. So this is the very important result which we have provided. All right. So I'm going to consider triangle ACF. In triangle ACF, what do we have? We have B is the midpoint of AC. That's the first thing we have. So let me write here. In triangle ACF, we have B is midpoint. B is midpoint of AC. Okay. And apart from that, what else do we have? We have BG, that is parallel to CF. Okay. Because if M is parallel to N, then BG will be parallel to CF, as BG is a part of M and CF is a part of N. Okay. Therefore, what can be said? Therefore, we can say G is midpoint of AF by converse of midpoint theorem, right? I'm writing the reason here by converse of midpoint theorem. Okay, midpoint theorem. Okay, and if that happens, then it can be said that your FG, that's equals to what? That is equals to GA. Okay, so we got this second important result. Okay. Now we are moving to the other triangle that we have in triangle FAD. So in triangle FAD, what do we have? You have FG is equal to GA. What does that mean? That means G is the midpoint of this line segment FA. And what do you have? You have GE, that's parallel to AD. Okay. FG is equal to GA. That means G is midpoint of FA. And EG is parallel to AD. So can we say that FE is going to be equals to ED or not? Okay, by converse of midpoint theorem. We can say that, right? And if that happens, then what can be said? It can be said that FE upon ED is equals to 1:1, or you can take the reciprocal also, that is ED upon FE is going to be 1:1. So the answer to this problem is going to be 1:1. So basically we used converse of midpoint theorem here in the two triangles that we have in front of us, that is triangle ACF and triangle FAD. But you have to decode the information which is given in the problem for the application of the two theorems that we discussed just now. I hope it's clear to everybody. Let me quickly go through it once more. What are we given? You are given AB upon BC is the ratio of AB and BC is 1:1. So that means AB upon BC is 1/1. And if AB by BC is 1/1, that means you can say AB and BC, they both have equal length. I don't know what length is, but they have equal length. And this implies that B is the midpoint of AC, right? So if you move to this triangle, let me highlight that thing. If you move to this triangle ACF, then in this triangle B is midpoint of AC, and also you have BG parallel to CF, as M is already given parallel to N. Okay, let me write that in the comment also. Okay, as M is parallel to N. Okay, so by converse of midpoint theorem, we can say that G is going to be the midpoint of AF, and G is the midpoint of AF means FG will be equal to GA. After that, we have to use this result in the adjacent triangle that we have. That means triangle FAD. So in triangle FAD, we have FG is equal to GA, and we have GE is parallel to AD, because GE is a part of M and AD is a part of line L, and M is already given parallel to L in this question. Okay. So by converse of BBT, converse of midpoint theorem, you are going to have FE is equals to FE is equals to ED. Okay. Or if FE is equals to ED, you can say FE upon ED will be 1/1, or ED by FE would be 1/1. Therefore, the answer to this problem is going to be 1:1, or the ratio of ED and FE is going to be 1:1. Is that clear? I hope this is clear to everybody. All right, then let's move ahead. You can check here what's the answer. The answer provided here is 1:1. And this solution you can refer whenever you would like to refer. Okay, they have done it in the same way. AB is equals to BC. BG will be parallel to CF as M is parallel to N. Therefore, by the converse of midpoint theorem, G will be the midpoint of AF, because that's what the converse of midpoint theorem says. And if I talk about the other triangle, which is AFD, AG is equal to GF, that we proved here. You can check out. And GE is parallel to AD as L is parallel to M. Therefore, by converse of midpoint theorem, you are going to have E as midpoint of DF, which means FE and DE will be same, and therefore the ratio is going to be 1:1. I hope that is clear to all of you. All right, let's see ahead. What do we have? All right, guys, now comes the interesting point. These two questions are for you guys to practice, but let me explain what all you have to do in these two problems. In the figure given below, LMN are the midpoints of the side PQ, QR, and PR respectively. PQ, QR, and PR respectively. This is R. Okay. If PQ is given 4.4, you are provided PQ as 4.4 centimeter, QR is provided 5.6 centimeter, PR is provided 4.8 centimeter, then you have to find out the perimeter of this small triangle that you have, which is triangle M and L, M and N. And it's very clear which theorem we have to use. You have to use here midpoint theorem. You try it. I'll see like how you are going to use midpoint theorem in this particular question. Okay. So this first one is very direct and it's easy, but the second one is important. Okay, because we use this result in many Olympiad problems as well. What does it says? It says prove that the four triangles Found by joining in pairs the midpoint of the side C. Midpoints of the sides of a triangle are congruent to each other. So basically you have to show that this triangle, let me name it delta 1, this triangle delta 2, that triangle delta 3, and this triangle delta 4. The four triangles which are formed by taking the midpoints of the three sides of the triangle AB, BC, and CA. D is midpoint of AB, E is midpoint of BC, and F is midpoint of CA. Okay, the triangle which we are getting as a result, which is DEF, that triangle is one of the triangle, and because of that we are getting three more triangle, this triangle, and that triangle. You have to show that all the four triangles that we got as a result, they are congruent to each other. You have two theorems to use. You can either use midpoint theorem or you can use converse of midpoint theorem. That's entirely up to you, but use it in proper way with the proper logic and reason. Okay, so these two questions you have to try as a homework. In case you do not get it, you are free to discuss with your subject faculty anytime. Okay, so I hope guys you have understood the topics that we did today. Okay, here you can find the answers to those problems. I hope you guys understood the two very important results that we discussed today. That is midpoint theorem and the converse of midpoint theorem. Make sure that you practice the theorem, the proof of the theorem. You know the statement of both the theorems by heart, and you also practice plenty of questions based on those two theorems to get a good command over those topics. In case you come across any doubt or any problem, even after practicing or going through the proof, we are here to help you out with that. All right, guys, thank you so much for attending session. See you all in the next one. Bye bye, take care.